Section 3.3, Measures of Position. If you took a test and I told you what score you got on that test, you might also want to know, well, is that about average? Is my score better than average, worse than average? Did I get the highest score in the whole class or the lowest score or somewhere in between? If you find out how much a bartender makes, you might also want to know, well, how does that compare to other bartenders? If you find out how tall a basketball player is, you might want to know, well, how does that compare to other players in the league? Is that player the tallest, the shortest, right around average? So that's what measures of position is all about. When you compare one score or data value or number to all of the others of the same kind or in the same set of data. So the first measure of position that we're going to be talking about is what's called Z-scores or standard scores. So they tell how many standard deviations above or below the mean a value is. So for any value from a set of data, the Z-score corresponding to that value would be what you get when you take that value minus the mean and then divide by the standard deviation. So that could end up being positive or negative. It would be positive if the value you started with was above average, and it would be negative if the value you started with was below average. So here's an example for this set of scores that we've looked at before, where most of the people scored above the mean of 80, but we had one person who scored way below. Here I'm showing you the Z-scores that correspond with each one of these test scores. Most of the Z-scores are positive. They're not very big, but they are positive, indicating that that score was above the mean by at least a little bit. And then for this last score, 35, that was way below the mean, the Z-score is negative. It's negative 2.94. So that's almost negative 3, meaning that a score of 35 is almost 3 standard deviations below the mean. And that's quite a bit. If you remember when I was talking about Chebyshev's theorem, we said that there can only be so many numbers that are more than 2 standard deviations away from the mean. So for a number to be more than 2 standard deviations away from the mean, that would mean that the Z-score is either a positive number bigger than positive 2, or it's a negative number below negative 2, and you can't have too many numbers like that. That's relatively rare to have a Z-score that is that far away from 0. Now we will do more with Z-scores later on in the course. Right now they're kind of a minor topic, but they will come back and be a lot more important in something we'll be doing in a later chapter. But for now, we're just making sure we know how to calculate them. So you calculate Z-scores by taking value minus mean divided by standard deviation. So the formula looks like either this or this, depending on whether you're using the symbols for a sample mean and standard deviation or a population mean and standard deviation. But either way, it's that number minus the mean divided by the standard deviation. So for example, let's say in 1 week, you took 4 tests in 4 different classes that you're taking. You had a test in history, you had a test in chemistry, in math, and in psychology. And here are the scores you got on those 4 tests. 82, 88, 84, 80. So all your scores were in the 80s. They're all pretty good, but you want to know, well, which score was best kind of relative to the other people in that class that took that same test. A score of 82, is that good? Is that bad? Is that above average? Is that below average? Well, looking over to the mean column, I see, well, that was above average, whereas the 88 that you got in chemistry was below average. But let's be a little more specific than that. Let's calculate Z-scores for these test scores that tell us how far above or below average each one of them is, so that we can say, which one did you do best on relative to the rest of the class? So first of all, for history, to calculate the z-score there, we take that score 82 minus the mean 77, and when you subtract there, you get 5. And then we divide that by the standard deviation, which is 2.5, and we end up with 2. So on the history test, you got a z-score of 2. That means that your score was 2 standard deviations above the mean, which is actually pretty good. On the chemistry test, your score was 88, the mean was 89, 88 minus 89 is -1, and then if you divide by the standard deviation 4, you get -1/4 or -0.25. So on that one you got a negative z-score, which means that your score was below the average by a little bit. So even though 88 is a pretty good score, it's still not as good at relative to the other people who took that test. It's below the average score on that test. Now what about math? On that test you got 84, the mean was 79, and the standard deviation was 5. So 84 minus 79 is 5, divided by 5 is 1. So +1. Positive because your score was above the mean, but it was only 1 standard deviation above the mean instead of 2, so not quite as impressive as how you did on the history test. And then on psychology, well, let me pull out my calculator for this one. So first I'm going to do this wrong. This is not the correct way to calculate this. I'm going to take your score, which is 80, minus the mean, which is 83.4, divided by the standard deviation, which is 5.6, and that came out to be 65.1 something. I told you that was wrong. Do you see why? Do you see why I put that in incorrectly? We're supposed to subtract before we divide, but the calculator does division before subtraction, unless I put in parentheses or something to tell it otherwise. So it first divided 83.4 by 5.6, and then it subtracted that from 80, which is not what we want. So the correct way to calculate this, at least if you're doing it all in one step, would be to put parentheses around the numerator, around the whole thing that you're dividing. So whenever you have a fractional expression and you're entering it into a calculator, it's a good idea to put parentheses around the numerator and the denominator. Now here the denominator is just one thing, so I don't really need parentheses around that. But it's parenthesis 80 minus 83.4, close parentheses, divided by 5.6, and that is the correct answer of -0.60714, and so on. Now for z-scores, we generally give those to 2 places after the decimal point. So always give your z-scores rounded to the nearest hundredth, to the nearest 2 places after the decimal point. So that means here we have a -0.60 with a 7, means this 0 rounds up to a 1. So rounded to the nearest hundredth, that's -0.61 for the z-score for the psychology test. So going just by your absolute score, you did best on the chemistry test. But relative to the rest of the class, you did best on the history test. Next best on the math test. Those were the 2 tests where your score was above average. And then on chemistry and on psychology, your score was below average. So still in the 80s, not a bad score, but just not as good as what some of the other people who took that same test did. So I'm going to end this part of the video right here, since we're done talking about Z-scores, and I will come back in the next part and talk about some other measures of position, like percentiles.